Hi there. My name is Daniel Rosenwasser, and I'm the program manager on the TypeScript team at Microsoft. Today, I'd like to talk to you a little bit about TypeScript and what we've been working on in the last year or so. Just to get the stage set, um, we should ask ourselves what TypeScript is. And if you're not familiar, it all started with this general problem space of where JavaScript scaling to more complex applications. Now, the thing is that JavaScript is being used in more and more places today. It's being used in more complex apps, and it's being used in bigger and bigger code bases. And yet, we're seeing ourselves running into the same issues that JavaScript code had 20 years ago as well. So we're finding ourselves running into typos and debugging issues with those for hours at a time in some cases. And that's just a lot of friction. That's a trivial issue to be running into. And so instead of actually running with JavaScript, you can imagine we are actually working with a language called TypoScript instead, which doesn't feel very good to use. And so we asked ourselves, what if we could correct this, right? What if there was a way to actually make it so that you could get a hint to what you're doing wrong before you ever run your code? What if you could just find out whatever's wrong as soon as you type it into your editor, and you get a little red squiggle just like you do in any word processor? And on top of that, what if we could give you the right tooling so that with just a click of a button, you can get a suggestion and select that suggestion and get a fix and get exactly what you want with a click of a button? And that's TypeScript. TypeScript takes JavaScript code and adds type declarations and annotations. Doing this signals to the TypeScript language what our expectations are throughout our program. So in this case, we have an X and a Y, and they're both numbers. And if we try to use something that doesn't exist on a point in this case, we'll issue an error message saying that the word Y doesn't exist on a point. Maybe you meant the letter Y. And because we understand your program more deeply, we can give you handy things like quick info, which is like tooltip hints. We can give you go to definition. We can find wherever a function is being called. And that's TypeScript. TypeScript is an open source cross-platform superset of JavaScript that runs wherever JavaScript runs. And we like to describe it as type JavaScript at any scale, because no matter whether or not you're using it at its extreme, if you're using the most typed version of TypeScript, the strictest settings that you can, maybe you're using untyped JavaScript as well. And actually, TypeScript is there to help you be more productive as well. So if you've used an editor like Visual Studio or Visual Studio Code, TypeScript is the thing that actually supports the editing scenarios in those editors, regardless of whether or not you're using JavaScript or TypeScript. And the way that we do this is through things like JS doc annotations. We use declaration files from Definitely Typed, which is a user authored repository of DTS files to describe third-party libraries to TypeScript. And that makes for a really solid editing experience. So no matter where you are on the spectrum of untyped JavaScript to heavily typed TypeScript, TypeScript is there to help you. And the way that we approach development is in an open way, right? So we're not just making this open source, we're actually doing everything in the open. Our aim is to closely track what the ECMAScript standard standardizes. And our focus is more in the type system. We're a fully erased type system, and that's been our focus for the last few years, right? Not adding any new features unless it's through the standards bodies. And because we have that understanding of your code, we're able to give you better tooling. So we're actually, like I mentioned, we're the ones who provide that great editing experience that you've used in VS and VS Code. And that makes for happier users. And so we really do try to leverage our type system knowledge in the editing scenarios. And throughout all this, whether it's through the editors, through error messages, through our documentation, we're trying to lower the barrier to entry because that creates a virtuous cycle of growing the community. So we think that pays off really well. And I always like to give a little teaser of how we've grown in the last year. And in the State of JS survey, in the State of JavaScript survey, there's this one category for languages, and one of the peculiar things here was that TypeScript was used by over 50% of surveyed users in this annual survey, which we have never gotten before. And in this specific case, not only that, but if you take that ratio of people who have used it and would use it again to just the overall people who have used the language, it works out to something like over a 90% satisfaction rating. And that's really exciting because it's not just an indicator that we're growing and, you know, that's always good, but we're growing and people are enjoying the experience, right? People like the product. It's not like they're being forced with a gun to their head to use this thing. They're actually voluntarily using it, and they would use it in another project. And there's plenty of room for growth here. And for the people who are not interested, we're hoping to understand why. We'd like to do better. We'd like to provide a better experience. And even if they're not interested in TypeScript, that's okay, because we believe we can still give them a better experience overall in the JavaScript ecosystem. So what's new in TypeScript? Well, the thing is, to answer what's new in TypeScript, you actually have to also answer what's new in JavaScript. Because, well, like I mentioned, TypeScript is a superset of JavaScript. But that means a lot of stuff, actually. In ECMAScript 2020, which got standardized over the last year, a lot of new features came in. And while TypeScript has had support for a lot of these, now they all have pretty broad adoption throughout different browsers, right? And I think the two most interesting ones here are maybe the BigInt type and the optional chaining and coalescing operators. So what are these things? Let's talk about integers for a little bit. Let's say I've got a really, really, really big integer, right? That seems like enough zeros. So let's check if this thing is equal to itself. And hopefully, as many of you have maybe built up an intuition, you got the right answer on this. This thing is going to be true. It's going to be equal to itself. But what happens if we try to change one of the digits here at the very end? And if you change it, like, clearly we can see that they're not the same, but JavaScript thinks that they are. And so this is kind of like an example of one of the classic WATs of JavaScript. But in reality, it's not that crazy. And the reason for that, well, it depends on who you ask. But the behavior is in a lot of languages, right? The same behavior is in C, it's in C# and Java and Haskell and all these languages that actually implement the IEEE 754 floating point standard, right? They all have this behavior when it comes to floats. But the thing about JavaScript is that there's really only one, or there was really only one numeric type in the language until recently. And so the fact that they use floats by default is kind of a classic, confusion for new users. But that's why JavaScript now has a new type called the BigInt. And so it has, if you want to write a really big integer, you suffix it with an n character at the end. So this is a BigInt. So if we use the type of operator, this is actually a new primitive type called the BigInt, right? And it has its own constructor as well. And you can use that to, create new BigInts as well from other types. And so, TypeScript has support for this thing. If we take a look at, this file here, let's say we have this really big number, right? And it's plenty of digits long, right? But if we look at this, we're actually getting a suggestion in the editor that says numeric literals with absolute values greater than this thing are too large to be represented accurately. So, while there's nothing technically wrong with writing the code, it is sort of questionable. And so in the editor, you'll get a suggestion to correct it and to switch it over to a BigInt. And so we'll actually provide that option. And with that, we now get an error message that says, well, you can't use BigInt literals when you're targeting anything lower than ES 2020. And there's a really good reason for that. And the reason is, if we did allow you to use BigInts in lower targets, we would also have to downlevel it everywhere. We would have to override every single operation, like equals and plus and multiplication. Like, all of that would have to be overridden in a way that makes it amenable to working with BigInts. And that was not something we were willing to do, because that would just totally kill the performance on all of your code. So instead of doing that, we just say that big-ints can only be used in ES 2020. And that's actually okay, because when you think about it, a lot of runtimes nowadays support the bleeding edge features, right? If you're using the latest node, if you're using the latest browsers, they all have support for big-int. And if you really want, there are probably other ways of getting around this, but we haven't heard from users that this is a major pain yet. And we believe this is just critical to evolving with the language. And so if we do something with this, like let's say we try to, I think there's some other behavior that is useful for using TypeScript with this. If we try to compare this to the number version of this rather than the big-int version, we actually get an error. And it says that this condition will always return false because big-int and number have no overlap, right? And that sounds kind of weird because, like, if we look at these things, again, this is one of those cases where if we visually look at this, it seems like it should be true, right? And that's actually not the case at all. If we go back to our REPL and we type this in, we do get false. And that's because JavaScript is actually trying to save you here. It's trying to make sure that you don't run into a lossy conversion where the right side of this operation would turn into a big-int maybe, but it would lose precision during that conversion, right? Because this thing is already not represented accurately in the first place. So TypeScript also helps you because you'll find out you're doing the wrong thing before you actually run your code, which is actually kind of neat, I think. So big-ints are really neat, and that means that you can write more predictable JavaScript code, I think. Another really cool feature is optional chaining and coalescing. Now, these two features are really neat, and they've also been very big, highly demanded features in the community for a while. So let me give you an idea of what optional chaining is to start. So you've probably seen code like this where you're trying to get a very deeply nested property, but at any given level of nesting, one of the properties could potentially be undefined or null or something like that. So what you might have written is obj and obj.prop and obj.prop.nested to say, well, if obj is there, then you can try to get obj.prop. And if obj.prop is there, then you can try to get obj.prop.nested. And at any point in this operation, if the left-hand side is null or undefined, the whole thing is going to be null or undefined. So JavaScript introduces this new feature called optional chaining. And the idea here is any point that you have a question mark dot, you check if the left side is null or undefined. And if it is, the whole expression, you say stop what you're doing, the whole expression is going to be undefined. But if it's there, you can dive a little bit deeper, right? So in this case, if obj is present, then you can get obj.prop. And if obj.prop is present, then you can get nested. But if either obj or obj.prop is null or undefined, value is going to be undefined at the very end. And this is super useful because compared to before and after, there's way less repetition, right? This is a classic example of do not repeat yourself, right? Do the thing that makes it more concise in this case. And this is a thing that we've seen in other languages too, and people really love it there. And this is one of the most upvoted issues on our issue tracker of all time. And in fact, we had to lock it at some point because we saw that the conversation wasn't getting productive, right? In fact, the top voted comment on the issue was something to the effect of, I want to see this before it gets standardized in ECMAScript. I want to see TypeScript just implement this thing because I would find more value in it than having to wait until ECMAScript who knows when. But that was not the right move to us. That was not really playing in the spirit of working with standards and whatnot. And so the thing that we did instead was we decided to work with the standards body. We decided to actually champion the feature for optional chaining and nullish coalescing. And actually, as of December, we championed it to what's called stage 4, which means it's effectively part of the new version of JavaScript. And so now it's part of the standard. It landed in ECMAScript 2020, and we were really proud of this. This is one of the latest new features that we worked with a committee to achieve. And we can show this in action, actually. We can dive into, let's write some of this code. Let's dive into the optional chaining folder here. So I'll give you an example of some of this in use, right? So let's say you've got a session interface, and a session has a user. And a user is present if the user's logged in, and otherwise it's just going to be undefined. And a user has a name, and what we want to write is a getDisplayName function that you can show maybe at the top right of the user's session, right, of the user's page when they're logged in. And so what we're doing here is we're doing the classic, AND operation. We're saying if session.user is there, then try to get session.user.name, and then try to, convert it to uppercase letters. But, that has the same sort of repetition. And so what we're going to do is we're going to write this from scratch, right? This is a very, basic example. It's contrived, but, bear with me just to see the authoring experience here. So we get session, we get a completion for that. And then when we hit dot, we get user. And we always have provided this visual indication, well, for a while we have at least, that this thing is going to be optional, that it's not going to be present. So we add a little question mark to hint, hey, you're going to have to deal with this in some way. But then what if we hit dot again? Well, until recently, we never provided any completions here. And the reason was we were trying to give you a hint that you had to specially handle the null or undefined value in some way, in something that was not going to be too invasive to your code. And so we gave you no completions, right? But in TypeScript 3.7, we said, well, now we have a well-known operation that's not too invasive. And so now when we hit name, we actually convert your dot to a question dot so that you can actually get the optional chaining functionality, right? And if we look at the return type here, it's still string or undefined, just like it was before. But now I didn't have to repeat myself with session.user, right? So then I can actually do dot to uppercase. And like I said, if the left side is null or undefined, the right side isn't going to be evaluated. We just return undefined for the whole expression. And so, same deal, right? If this thing is undefined, then we're going to get undefined for the whole type, for the whole value. Otherwise, we're going to try to uppercase the name. So this is really neat. And we were able to cut down on some characters, which is nice. But, I'm not really satisfied with the fact that this thing potentially still returns undefined. So I want to give it a default value. So what I'll do is I'll say, I'll say something like no user logged in, right? This is going to be user facing, and I'm sure that our UX person is going to hate it, but let's just roll with it, right? So now you do get string, right? But the thing about this is that we're a little bit overly eager about giving a default value. And what I mean is that this double bar operator, the OR operator, is often used in JavaScript for saying if the thing on the left is null or undefined, pick the thing on the right. But in this case, it does something that might be a little bit questionable, right? It actually checks if the thing on the left-hand side is also falsy. And so because we're dealing with strings on the left side, we have one specific falsy value, which is the empty string. Now, maybe that is or is not a bug in the system, right? Maybe you actually can have a name that's empty and you don't want to display them as not logged in. But you can imagine this for other use cases as well, right? For example, you can imagine this is an age field, right? And an age could potentially be 0 if the person's age is, the person is an infant, right? Like they haven't grown to 1 year old, right? So instead of using the double bar operator, we can use a new operator called the nullish coalescing operator. And the idea here is this is a true defaulting operator that checks if the left side is null or undefined. And if it is, it returns the right side, right? Just the same thing that you were doing before, but it doesn't account for strings, numbers, booleans. It doesn't check for falsy values there. And so, of course, the value is the same. I mean, the return type is the same. You still get a string here. But you're able to now avoid trivial issues like falsy values. You don't have to write a whole bunch of code to say if this thing is double equal to null. and handle it in a ternary, which is kind of gross, or capture in a variable. So we're really proud of this one. This is one of the more recent examples of us working closely with the ECMAScript with TC39, and so not to spend too much time on ECMAScript itself, but this is a big part of what makes TypeScript even easier. But there's also the type system specific stuff, and I think an interesting feature that we've worked on over the last year is called uncalled function checks. And this actually came from a community pull request. But the idea here is, let's say that you've got a user interface, right? And the user has an isAdministrator method on it, and it returns Boolean. Now, in JavaScript, functions are values, which makes the language really, really flexible. It makes it super easy to use. But unfortunately, it means that it's the source of a lot of issues like the following, right? In this case, I don't know if it's clear to you, but we've got this erase all data function, and we, before we try to actually erase everything on the system, we say, is the current user logged in as an administrator? And if they are, then we'll actually delete all the files. But we're not doing the right check. We're not invoking the function. That's the problem. And so we're just checking if the function is present, and because it will be, it'll always return true. And we've got an error. We'll always erase all the files on the system, which is bad. So instead, we have this new functionality called uncalled function checks. And the idea here is we test a couple of different things. First, if you're in strict null checks mode, and the thing isn't declared as optional or undefined or any of this stuff, and the thing that you're checking on inside of the if is not used in the body, then we assume that you're probably doing something wrong. And so we say this condition will always return true because the function is always undefined. Did you mean to call it instead? And so now we actually provide you a quick fix to say, hey, add the parentheses, actually call this thing. And now we get the right code, right? Now it works as intended. Now, you might think that that's a trivial error, right? Like a linter could maybe do that. And yeah, it could, but this provided so much bang for the buck that we decided it was worth putting into TypeScript proper. And in fact, we caught a lot of really useful bugs. One of the bugs that we found was in using this stat function, right? So in Node, there is a function called stat, and stat returns an object with a whole bunch of methods on it, like is file, is directory, and is symbolic link. And one of the interesting things was, a bunch of code that is written like this to check if a file entry is a directory was never getting called. And so this meant that in other branches, you would never check if you had a symbolic link. You just always assume that this thing was a directory. And this is actually specifically code that we found in the Visual Studio code base. And someone out there was probably running into really funky behavior, which was not anticipated. But they never knew about it, and they probably never knew how to report the bug. But because we had some level of basic static analysis, we were able to give a nice handy error message to say, you're probably doing this thing wrong. Do you want to rewrite this code? And that's something we were all really excited to see. Obviously, the VS Code developers were really happy about it too. Even if it is giving more error messages, more errors, these things make better software. That's the thing. So now you can write the correct code. Another thing that I want to show off is this new functionality to run declaration with allow.js. Now, I don't know if you're all familiar with this. Oops, let me dive back in there. I don't know if you're all familiar with this, but we have a flag called -- declaration. And the whole idea of this flag is to create DTS files. And declaration files are the things that allow us to get good information from, what do you call it again? Sorry, I'm blanking here. Declaration files are the files that allow us to actually interface with the outside world of TypeScript, right? So if you have a library like Lodash, there's a declaration file for Lodash that says, here's the API for Lodash, here's how you can use it, here are the correct types, all of that good stuff. And it also is used to make compilation faster against existing TypeScript libraries, because instead of type checking all the existing TypeScript code, you can just abridge the code with the signatures of your methods and functions and the type declarations, and it becomes a lot more compact. And that makes compilations faster. And another feature that we've had for a while is the functionality for allowing TypeScript to work with JavaScript libraries. So, one thing I alluded to before was that TypeScript powers the JavaScript editing experience in VS and VS Code. So what does this mean? Well, if I hover over input, it says that it's a uint8 array. And if I hover over width, it says it's a number. And it's actually getting all of this information from the JS doc comments right here. And, as soon as I do these assignments, inference just works. It just lights up. So I can say input dot, and if I can actually correct it, can write things correctly, I can get the completions for every method and member on input as well. And this all works really well in conjunction with this tscheck flag. So with tscheck, I can actually catch errors before they happen. So I can multiply a string by a number, and it'll tell me, hey, you can't use a string in a multiplication, right? And of course, I can turn off tscheck if I want. I can say tsignore, I know what I'm doing. And this is all super handy stuff because it allows you to gradually adopt TypeScript, or maybe you're a Node user and you're not sold on having a compilation step, right? Compilation has become a lot more common in the front-end world, but a lot of Node users have a sort of aversion to it because it just adds this extra layer of friction, because people are already running the latest versions of Node, which has all the latest versions of JavaScript. So we've seen an uptick in this style of coding. People have really enjoyed this. But the thing is, until recently, you couldn't emit a declaration file for this JavaScript library, right? And so now one of the things that I can do is I can open a console and I can go into the blur image folder, and I can run npx tsc, and I'll just show you the tsconfig while that happens. We have declaration in allow.js to be true. And like I mentioned, this was previously not allowed at all. But if I look at the lib directory now, I see my JS file, right? And it looks pretty much like exactly what we had. We don't exactly preserve the new lines between code, but we try to do a good job of preserving the style that you wrote your code in. But alongside that JS file is the DTS file. So now we actually do work with this thing. And not only that, we export this thing to something that looks exactly like the TypeScript equivalent code. So here we have an export. We have modern syntax for exporting. We're using TypeScript annotation. So we say :uint8 array. We also preserve the JS doc annotation, right? So this is useful because now you don't have to, munge around with trying to get all the information or rework. It's all just done for you. And what that means is that if I jump back to, let's say, the optional chaining example, and we try to import for this thing, and we're not really set up right now as a monorepo, we don't have things symbolically linked, but I could say import from blur image / libs. Yeah, I think that's it. And now I get the blur image function, and now I get all the good functionality because I have a DTS file. So I also get doc comments, I get signature help, I get quick info. All that stuff is still there because TypeScript was able to power that experience through the DTS file, which was provided through JS doc that was understood by TypeScript. And so we're really bridging the gaps between these experiences depending on what you're trying to go for when you're authoring. So this is what I meant by type JavaScript at any scale, right? If you're totally untyped, we'll try to get DTS files for you automatically in the editor. You can start leveraging editor functionality by using JSDoc. You can add the tscheck comment to the top of your file. And, it all just works out really nicely. And then you can even convert this to TypeScript if you really want. And we have some refactorings and quick fixes for you as well. In fact, we even have a way to convert this to an ES6 module. And, it's a little it's not exactly what you might have written, but it is technically an ES module now. So, that's something that we're really excited about, because this is something that we have been surprised has enabled a lot of JavaScript users to say, hey, actually I might use TypeScript now because I can avoid new syntax that I'm not quite used to. I can avoid a compilation step, but I'm still able to just get automatic doc comments, right? It encourages us to use best practices, and a lot of people end up actually saying, well, this TypeScript thing is pretty great. I'll just use the new syntax. So it's really a stepping stone. But even if you decide not to just go into TypeScript, you have a really useful tool. Another neat thing, and this is something that is part of the ECMAScript thing, the ECMAScript standards process, but it isn't part of ECMAScript 2020. Is private fields. So a lot of people have complained over the years that TypeScript has privates, but they're not truly private. And that's part of what the private fields proposal and TC39 has been all about. Is what if we could provide true API privacy in JavaScript? And so this is something where I think showing off the example in code would be helpful first. So I'll say, let's create a new person, and if a new person has Jeff, let's say Fizzle Bizzle. I think that's a real name. And we can do console.log, let's say first name, right? Let's save this thing, and then let's run node on it, right? So let's get out of here and go to the private directory, and let's run npxtsc watch on this directory. Let's go into the private directory again. Okay. And now we have a lib directory, and we can just run the node code, right? So if we look at the lib directory, notice that first name and last name just look like ordinary property assignments. And that means we can do whatever we want with them, right? So we can say node lib, right? And it just emits the word Jeff, right? What if we try to make these things private in TypeScript? So now we get a compilation error, right? We get a property first name is private and only accessible in person. But if we try to run this again, actually I'll delete this just so that you can see that something actually happened. And I can run this again, and still we end up with the same code, right? And the idea here is that private is just part of the type system. Like I mentioned, TypeScript tries to keep this stuff erasable, meaning that it has no effect on the runtime of the program. And so that's part of why in the ECMAScript standard, there's a new proposal for class fields that includes something called private fields. And so what we can do here is we can change this code to use what's called a private name. And a private name just leads with a hash, right? So now, if you try to do this thing, you'll still get the same compile error, right? But if you look at the output, or if you try to see what happens here, you actually see that this doesn't work, right? In the runtime, this thing just errors. And that's because, well, we're using it this is not valid outside of a class in the first place. So you're getting true runtime privacy that's enforced by JavaScript, the language. And there's also ways of downleveling this too, right? So we're using ES Next, but we can also emit to ES 2015, which is the oldest version of JavaScript that supports this. If we try to run this again, we use a bunch of stuff for emit purposes, right? And this isn't the most beautiful code, but it is semantically the same, and it uses this thing called weak maps. But notice, because this thing can't be represented, we just won't. And so, even if you try to get this working, you're really fighting against the emitted code at that point, right? So this won't work at all. And if you try to use an instance property outside of this class, you'll just end up with errors. Um, and so this is super handy if you have been trying to use classes, but you're still missing a lot of the benefits of closure properties in JavaScript, which never leak things explicitly in the first place. Um, and now, if you're trying to decide between TypeScript privates and ECMAScript privates, um, my suggestion is often if you really 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 need to protect some data from like external code, um, that you don't want anyone else to really take a hard dependency on, then maybe ECMAScript privates are for you. But if you can basically signal intent, and intent is enough, right? Like, you can think of TypeScript privates as a stronger version of adding a leading underscore. So you'll get a compile error, but the code may still run. That's more of what's the word that I'm looking for here? It's a cooperative model where you have to basically have a shared understanding of collaborating instead of people trying to go behind your back. And if that's okay for you, that you probably want TypeScript privates instead, because those are a lot more efficient, right? Because if you need to target an older runtime, this is not going to be faster because of all those shims that I showed you. But I think this is also a cool feature because this happened in collaboration with an external partner team at Bloomberg, because they're heavily involved in the standards process and they wanted to try to drive the feature forward. And we were happy to collaborate with them and get them acclimated to the code base. And they've been really helpful in other manners as well. So we've been really happy with that work. And worth mentioning is always faster builds. Over the last year or so, you may have heard about project references, which is a great way to break apart your project into different compilation units or program compilation units. So imagine like a client source and a server, where the client and the server can both, a client shared in a server directory, and the shared one doesn't need to be compiled twice for both the client and the server, right? So project references can help there. We've also added the incremental flag, which allows TypeScript to figure out which files have been edited and which files need to be re-type checked and re-emitted. And that's for most people just free perf, right? If you're not using the incremental flag today, definitely get on that and see if it helps, because most users we've seen have seen a great improvement. Last time I was on stage doing this presentation, we showed off how VS Code's compilations on a worst case scenario went down from 50 seconds to 10 seconds on a cold compilation where TypeScript isn't already loaded into memory, which is tremendous. But the thing that we're focusing on mostly nowadays is type checking improvements. And this, a lot of these come down to these heavily combinatorial types, right? Because a lot of libraries are built on React, and React tries to model the DOM, and the DOM has like many tag names that it deals with, right? So if you look at JSX.intrinsic elements, it's dealing with all these tag names from XML, from SVG and HTML and all of that stuff. And then on top of that, each of those tag names maps to a specific type of properties object. And, a lot of people try to slice and dice these property objects by saying, well, filter the ones that, have an href attribute, and get rid of the ones that do this and add the ones that do that. And these slicing and dicings are okay in small doses, but the thing is that these things get regenerated on every single keystroke, which is really inefficient. So, we're doing a lot of work to try to do, be more efficient about these things. And a good stress tester of this is Material UI, which isn't a huge project, but they have this directory called Material UI styles, which takes up about, almost 11 seconds to compile, based on just check time alone, type checking time. And we were able to get that under 7.5 seconds or so, which, is a pretty nice improvement overall, right? Like that's real compilation time that, as you have a bigger project that uses more and more of these types, you pay less, right? You end up feeling it a lot more as you get those savings back. And so, this is still not the most ideal, but this is something that we're taking really seriously. We're trying to say, what are some code bases that we can make more optimal? What are some ways that we can make type checking faster? And so that's our current goal. And it's, this is an improvement that's coming in TypeScript 3.9, or, well, has come in TypeScript 3.9 at this point. Still getting used to that. And we're going to be continuing to investigate in this stuff. And you can keep a track of our investigations on GitHub. If you have a really slow code base, we've written up guidelines on diagnosing this stuff and helping us find, dig into the issue. And we're also investing in tooling to try to help ourselves investigate this stuff so that we can make things faster. So things we're considering at this point are diagnostic tooling for just slow compilations, trying to find the statement in your program that takes the most type checking time, and an efficient logging to try to find out like what's the slow operation in day-to-day editing scenarios. So this is all super great, right? Like this is an improvement where, in Office, this is Ken works on the Office team. And just by upgrading to TypeScript 3.9, they went from a compilation time of 26 seconds to 10 seconds, which is over half the time. That's something that, I cannot guarantee that you will get a 40 to 60% improvement in your compilation time. But I mean, yeah, maybe that's something that's interesting to you. And you should definitely give that upgrade a try if you're not already upgraded today. So, and then another thing that we've been really taking seriously is the UX, right? One of the fundamental things that people get is, the fundamental thing that we offer is error messages, right? And I'm not saying our error messages are beautiful like the pyramids. That's not why I'm showing this slide. I'm not trying to say like we're this grand architecturally beautiful thing. I'm showing you this because these are nice looking pyramids. And these are what we call not nice looking pyramids. These are our error messages, our pyramid of doom error messages that we sometimes get from users. And it's not something we're proud of. It's not something we're oblivious to at all. We know that these are not great. And a lot of our community reminds us of this. People have turned it into a bit of a meme, right? Like, get this awful error message and it is totally unbearable. And look, we know, but we're trying, and we're not trying to do it through revolution, but rather through evolution, by taking individual steps to find heuristics and better approaches to doing things more nicely, right? So this is something that I showed a while back. This was an effort from about 2 years ago. Of trying to give a better UX, and we would specifically think of individual things. And one of the basic things from back then was, instead of erroring on the entire object, error on like the individual property that's the offender here, right? And so this is basics, but then we started doing some other really cool things too. So for example, we've got an array of number or a map of some stuff, and an array of strings. And we're trying to assign the array of strings to that union type above, right? But the error message is giving us a pretty bad elaboration. From TypeScript's perspective, it's saying, well, I'm going to try to assign the array of strings to all of the things in the union, right? The array of numbers and the map of whatever. And if none of them are assignable, I'll just pick the last one, because none of them are assignable, right? But that's a really robotic sort of approach, right? Like, that's like technically correct, which is like not helpful to anybody. It's not the way a person would explain that concept to you, right? If you ask me, I would say, well, you got an array of strings, and the only thing this could have taken was an array of numbers if you wanted an array. And so the idea here is assign the like types to each other. So in this example, we specifically try to find the better type. We say the array goes to the array. And that's a basic thing, but it helps so much. Another really useful thing is, if you're coming from a language like C++ or Python, this is a really easy beginner issue where people say, oh, well, if I've got a map, the thing I should try to do is index into it with square brackets. And that's not how that works in JavaScript. Actually, you need to call the get method. And so TypeScript specifically has heuristics in place to say you probably meant to call get. And we have a quick fix for that. And we also have things like, did you forget to call this function? And it's all about giving a better experience, hinting you to the pit of success, right? And this is my favorite one, and this is the most recent improvement, which is this is the classic example of a pyramid of doom because of some deep sort of property that's incompatible, right? And the thing is that it says, well, these two very big types are incompatible. Well, why? Well, because A is incompatible. Why? Well, and then it says the type of A and for both of them, and like you don't really care. But then it says because B is incompatible. Why? Because C is incompatible. And it does this over and over, and it has two layers at each step. And the thing is, like, really what you want to say is A.B.C.D.F. whatever is incompatible. And that's actually exactly what we do in newer versions of TypeScript, is that we specifically try to collapse this whole thing together and say this expression would be incompatible between these types. It's not exactly the syntax, but it gives you a good indication of something like breadcrumbs to figure out what went wrong without, giving you an accordion of error messages. So we're really happy about that. And it's all about making users happier through things like this, right? We try to be transparent. We try to have public release dates and iteration plans and roadmaps. Our team members are involved on the issue tracker, and we try to be honest about our motives and be explicit about our concerns and things like that. And we do this not only on the TypeScript iteration plans and roadmaps, but we also do it for things like our website, right? So our website has a roadmap, and we've been rolling it out with public previews on the weekends occasionally. We've been trying to make things more approachable. And we think that this really pays off, right? Like, users are delighted. And, when they're not delighted, we take that as an opportunity to try to understand what we could be doing better. We try to embrace criticism. We try to understand why people are unhappy. And we're constantly iterating here to give a better error message. So people see the sorts of things that we're doing and they say, this could have been better, and we'll turn that around into actionable feedback within a day or so, right? And we love it, right? We're very proud of this. So, that's TypeScript. Like I mentioned, we try to be open in our approach. We try to stay close to the standards, and not only that, but we collaborate in the standards body. And our primary focus is in the type system. But while we do that, we also try, like I mentioned, work in standards. We try to provide the good tooling that you all know and love in VS and VS Code. And we're trying to get better at being more approachable. And hopefully that resonates with you. And if you feel like that's something that you want to help out with, like I mentioned, we're open source. We're looking for contributors for a whole slew of issues. We're looking for input. We're looking for ideas. So get active. If you're not familiar with TypeScript, go to typescriptlang.org today. If you want to get involved and just stay up to date with the news, we have our blog and we have a Twitter account that we try to actively post to. And just stay up to date on GitHub, where we have our iteration plans and our roadmaps, and you can just file issues if you ever run into anything funky or that you think could be improved. So thanks so much. I hope you enjoyed this, and give TypeScript a try if you haven't today. All the best.